Okay, welcome back. We're going to get started with chapter 4, and as I mentioned to you the last time, and as you could see by my screen, in chapter 4 we're going to be doing a lot of graphing. So I had mentioned to you that if you have graph paper or at least a ruler to help you out, draw some lines, that may come in handy. Um, so when we are going to be talking about graphing, we're going to be talking about graphing on what we call the coordinate plane. Now, when we talk about the coordinate plane, it is basically made up of two number lines. We, of course, have the horizontal number line, and the horizontal number line is often referred to as the x-axis, as well as we have a vertical number line, and the vertical number line is often referred to as the y-axis. And you can see here that we have these four gridded areas here. And these four areas are actually called quadrants, okay? Just some background terminology that you might or may not be familiar with. Quadrant 1 is in the upper right-hand corner. In quadrant 2 is in the upper left-hand corner, moving counterclockwise. Quadrant 3 is in the lower left, and quadrant 4 is in the lower right. And we use these Roman numerals to represent them: 1, 2, 3, and 4. Okay, so those are the four quadrants that make up your coordinate plane. Now, where these two lines meet right here in the middle has a special name for it, and it's called the origin. It's where we usually begin things, all right, in terms of graphing and plotting points. And as you can see, if we were to put the numbers on the number line, the positive numbers would go in terms of the x-axis to the right: 1, 2, 3, 4, 5, 6, and so on. The negative numbers, as we know, go to the left: -1, -2, -3, -4, -5, and so on. When it comes to the y-axis, the positive numbers go up: 1, 2, 3, 4, 5, 6, and so on. And it stands to reason, therefore, that the negative numbers would go down. So we would have a -1, -2, -3, -4, -5, and so on. So within the coordinate plane, we have both positive and negative numbers that move along both the x and the y-axis. And what we can do with this coordinate plane is we can plot points. Points has many different names. When we refer to points, sometimes they are referred to as coordinates. Okay. Another name for points or coordinates is ordered pairs. Now your ordered pair looks something like this. It's two parentheses. We're going to have two numbers, an x and a y number, and they are separated by a comma. Do not confuse this ordered pair notation with interval notation from the inequalities that we did in chapter 3. An ordered pair is a precise location, it is a coordinate, it is a point on your coordinate plane. So, for example, let's say we wanted to be able to plot a few points. Oh, and by the way, the origin has a very special coordinate, a very special ordered pair, because the origin occurs in between -1 and 1 along the x-axis and along -1 and 1 along the y-axis. So the ordered pair that represents the origin would be 0, 0. Okay? So let's take a look here for a moment. Let's say we wanted to plot a few points. Let's say point A has a location of maybe 3, 5. And we want to plot point A on the coordinate plane. So we're going to start here at the origin. Okay, that's 0, 0. And what we have to do, since your point is made up of an x and a y, we're going to move along the x-axis, and then we're going to move along the y-axis. Where do we move along the x-axis to put point A? Well, first we have to move to the number 3. So if I'm here at 0, 0, and I need to move along the x-axis to the 3, 1, 2, 3, this is where the 3 would be, along the x-axis, but then I would also have to move 5 units in a positive direction when it comes to the y-axis. So we're going to go 1, 2, 3, 4, 5, and this would be the location of point A. Its coordinates would be 3, 5, because we moved 3 units in the positive x-axis, and we also moved 5 units in the positive y-axis. Okay? And that's where we would put the point for point A. Let's say point B we want to plot. And point B has a different location, a different coordinate. Point B might be located at -4, 2. And let's plot that particular point. So once again, we go back and we start at the origin, but we have to move along the x-axis first. This is an ordered pair, and order does matter. We follow the alphabetical order, and so we move along the x-axis to a -4. Well, if we're talking about the negative x values, we'd have to move to the left. So we're going to go 1, 2, 3, 4. That's where -4 would be, along the x-axis. But then from that particular location, we also have to move 2 units up in the positive y direction. So that would be 1, 2. And it's here we would put our point that represents B. That's the location, that's the coordinate of the ordered pair, point B, located once again at -4, 2. Let's just do maybe a few others. C, a different point, might have a different location. That might be located at, let's say, -4, -5. Well, we already know where -4 is in terms of the x direction. So here's the -4. But now we have to move 5 in the negative direction in terms of y. So that would be means we have to move down. 1, 2, 3, 4, 5. And this would be the coordinate, the location of point C, because it has the ordered pair of -4 and -5. Let's say I was to give you this point. Here we have point D. And point D is located on the graph. We need to come up with the coordinates. Okay, we now want to come up with the ordered pair, the x and the y value. Well, in terms of x, we're not going to the right in the positive direction. We're not moving to the left in the negative direction. We are staying right here at 0. So 0 would be the x value in terms of the coordinate for point D. But then, to get point D, we have to move along the y-axis 1, 2, -3. So 0, -3 would be the location that we can come up with for point D. And it's very important that we're able to plot points, okay, come up with coordinates, okay? They are locations. You have to pay close attention to the order because order does matter, okay? X must come before Y, all right? Now, what we can do with coordinates, okay, and the coordinate plane, is we can actually graph equations. All different types of equations you're going to learn how to graph over the course of this semester. And here, in this particular section, we're going to graph equations that are in fact linear equations. These should form a straight line when you go to connect the dots, okay? So that's what we're going to have with linear equations. You will always form a straight line, okay? So what we're going to take a look at, first of all, is an equation in what we call standard form. Now, standard form looks in a particular fashion. AX plus BY equals C, where A, B, and C are going to be numbers. You're going to have two variables here, X and Y are going to be variables. For example, let's say we have 2x plus 3y equals 12. This would be an example of an equation in standard form. Or we may have, let's say, 4x minus 5y equals 20. Here we have another equation in standard form, okay? This is going to just be one particular form of what we consider a linear equation. And we're going to want to be able to graph these equations. Now, how are we going to graph these equations on the coordinate plane? Because we have two variables, x and y, you're going to need 2 points. Once you have 2 points, that will be enough information in order for you to graph these linear equations that are in this standard form. And we're going to work with two very special points when we have standard form. First, we're going to have what we call the x-intercept. And the x-intercept, by its definition, is the point where the line crosses the x-axis. Okay? So the point where the line crosses the x-axis is referred to as the x-intercept. And how we're going to get the x-intercept is you want to take c divided by a, those two numbers, comma 0. That's the location of the x-intercept. Now that's one point. We also want to do a second point, the y-intercept. And the y-intercept has a similar definition in that, of course, it is the point where the line crosses, of course now, the y-axis. And it has a similar formula. To get the y-intercept, you're going to do 0, comma, c divided by b. Okay, so two variables, x and y, you're going to have 2 points. Okay, the x-intercept and the y-intercept. Those are the 2 points that you need. Let's try an example. I gave you that first equation of 2x plus 3y equals the number 12. Now, this is an equation in that standard form, okay? So, let's see what we got going on here. Let's pick a different color. So, this is your ax plus by equals c. This is your standard form. A is 2. B is the number 3. C is the number 12. And we need the x and the y intercept. Well, first let's calculate the x-intercept. And to get the x-intercept, we have to take your number c divided by the numerical value of a, comma 0. Well, c is the number 12 divided by a, which is the number 2, comma 0. So we're going to have, when we simplify, a point, an x-intercept at 6, 0. That's one dot. That's one point. We also need the y-intercept. To get the y-intercept, we use this other formula, in which case we have to now do 0, comma. Now we have to take that same value of c, which is 12, and we're going to divide it by the b value, which in this particular case is the number 3. When we simplify this fraction of 12/3, we of course would have 0, comma 4. And that would be the location of our second point. So let's start by drawing our coordinate plane. Here's our coordinate plane. Next, we have to plot our two dots. We need the dot of 6, 0. So let's see, here we are at the origin. I have to move 6, 1, 2, 3, 4, 5, 6. Here's 6, 0. And then I need a second point at 0, 4. So I'm at 0, 0, and I have to go up to 4. 1, 2, 3, 4. And there's my second dot. So I have the x-intercept at 6, 0. I have a y-intercept at 0, 4. And so now when I go to connect my dots, I should try to form always a straight line. And sure enough, we do. Okay? This line represents every single x and y value that will make this equation true. The 2x plus the 3y equaling the number 12. Okay? That's how we're going to graph equations in that standard form. Let's try another one. Let's say we have an equation now of maybe negative 4x minus 6y equals a negative 12. We want to graph this equation on the coordinate plane. Okay? Let me start by putting my coordinate plane up. Here's my y-axis. Here's the x-axis. I'm going to identify what is A, B, and C. That might help me. So this way I can figure out what my points are. So we have AX plus BY equaling C. And once again, we're going to start with the x-intercept. To get the x-intercept, remember we have to do C divided by A, comma 0. Well, C is a negative 12. A is the negative 4. And when we simplify that, we get an x-intercept of 3, 0. So let's plot that point. Here I am at the origin, and I have to go 3 over 0. So there is my x-intercept. Next, let's get the y-intercept. Recall the formula, 0, comma, c divided by b equals, well, 0, comma, the value of c, negative 12, divided by b, which is a negative 6. And when we simplify that, we have the ordered pair of 0, 2. So let's plot that particular point at the origin. I have to move up 2. There's the ordered pair for 0, 2. I have plotted my 2 points. If you have 2 variables, you always need 2 points. Once we have the 2 points, we can go and connect the dots. When you connect the dots, you form your line, and that is your graph of that particular equation. Let me give you one to try. Let's say we have 5x minus 2y equals 10. Take a few minutes, graph that, pause the video now, and try graphing it on your own. And then when you return, once you have your particular graph, and let's compare it with mine. Well, let me start by graphing my coordinate plane. Let me put up my x and y axis. Here's the x, here's the y. Once again, let me label my equation ax plus by equals c. I first want the x-intercept. Remember, the x-intercept has the formula of c divided by a comma 0. What is the value of c but the number 10? Divided by a, which has the numerical value of 5, comma 0. So we would have an x-intercept at 2, 0. And let's plot that point. 2, 0 would be right here. Next, let's figure out what's the location of the y-intercept. To get the y-intercept, we would use the formula of 0, comma c divided by b. Plugging in our numbers, 0, comma, c is still 10, b is a negative 2, so we would have a y-intercept at 0, negative 5. Well, let's plot that point, and that would be over here. So we have our x-intercept, we have our y-intercept. Now let's go and connect the dots. And as always, you should try to form a straight line. Okay. This line here, once again, excuse me, represents the graph of that equation of 5x minus 2y equaling 10. Okay? You'll notice that always the line is slanted, diagonal. And once again, that is because you have 2 variables. Okay? I had said earlier that when you have 2 variables, you must have 2 points. And when you have those 2 points, you will always form a slant or diagonal line. Okay, very important. Okay, so when we have an equation in standard form of ax plus by equaling c, you'll notice you'll have 3 numbers for a, b, and c. X and y are your variables. And because we have the 2 variables x and y, you need to find 2 points, the x and the y intercept. And when you graph those points and connect your dots, you should always form a slant or diagonal line. 2 other lines that we're going to take a look at: vertical and horizontal lines. A vertical line is a line that goes up and down. Okay? And all vertical lines have the same equation. Okay? It's not going to be standard form, okay, that would form a vertical line. Your vertical line will take the form of x equals a, where a equals a number. For example, we might have x equals 3, or I could have x equals a negative 5. And I want to graph these vertical lines on the coordinate plane. And it's very easy to do, okay? Don't be confused. Now here you'll notice that all we have is one variable. In this particular case, the variable is x. And because we only have one variable, all you need is 1 point. Unlike the previous problems where we had two variables, x and y, you needed 2 points. Here, we have just one variable, the variable x. And since we have just the one variable, the variable x, all you're going to need is 1 point. So let's say we want to look at the graph of these. The graph of x equals 3, all you have to do is move along the x-axis to the positive 3. 1, 2, 3. And you put a dot. That's 3 on the x-axis. And since we have 1 point, we can now draw a vertical line through that 1 point. And that would be the equation for x equals 3. Okay? One variable only requires 1 point. Let's say we want to graph the vertical line, the equation, x equals a negative 5. Once again, I have just the one variable x, so therefore all I need is the 1 point. So I'm going to move now once again along the x-axis to the negative 5. 1, 2, 3, 4, 5. And I put my 1 point at the negative 5. That's the one dot that I need, the 1 point that I need, because it's x equals the negative 5. All I have to do now is to draw a vertical line through that 1 point, because that represents the graph for x equals a negative 5, nothing else. Okay? The last type of line that we have to take a look at today is, of course, not vertical, but horizontal lines. Now, horizontal lines are going to look a little bit different in terms of the equation. Horizontal lines take the form of y equals b, where b equals, once again, a number. For example, I could have the equation y equals a negative 2. I could have the equation y equals a positive 4. Once again, we have just one variable. A different variable, but it's only one. And if we have one variable, all we need is 1 point. Okay, one variable only requires 1 point. So if we wanted to graph this on our coordinate plane, let me start with my coordinate plane lines. And now when we want to graph these equations, if I want to graph y equals a negative 2, I'm going to have to move along the y-axis, and I'm going to move down to the negative 2. One variable requires the 1 point. And because that one variable is the variable y, I know it has to be a horizontal line. So you draw a line through it. If I want to graph y equals 4, this is the equation y equals negative 2. Now I want to graph the second equation, y equals 4. So once again, I start at the origin, and I have to move up 4 units along the y-axis in the positive direction. 1, 2, 3, 4, and I put my 1 dot, okay, because that's where y equals 4. And since we know we now have just the 1 point for the one variable, and that variable happens to be the variable y, I know I must form a horizontal line through that one point to graph the equation of y equals the number 4. Okay? So this is just an intro to graphing right now. Okay? We have seen 3 types of lines. We've seen standard form. Okay? Once again, with standard form, we have the 2 variables. We have ax plus by equals c. And since we have these 2 variables, x and y, those 2 variables will require us to have 2 points, the x-intercept and the y-intercept. Those are the 2 points. And what we see here is how we get them. Okay, this is kind of like a little formula to follow. Once you have the 2 points, you plot the points and connect the dots, and you will form your diagonal line. The other types that we saw, the non-diagonal, the non-slanted lines, initially we saw vertical lines. Vertical lines take the form of x equals some number, okay? Whether it be any positive or negative number, we have the one variable requiring only the one point. Since it is x, we know it's going to be a vertical line. Lastly, we have the horizontal lines that form of y equaling some number. Okay. Once again, we have just the one variable y requiring the one point, and we draw a line through that one point. All right. So that completes section 4.1, an intro to graphing with 2 and/or 1 variable. We will continue with this in section 4.2 next time, where we will be talking about a very important concept called the slope of a line. Okay? Until then, try some of the homework problems that go along with section 4.1. If you have any questions, please feel free to email me. Until the next time, be well.